We'll start in a few seconds. Today we'll continue the test 4 review, and then on Friday is the test 4. Take advantage of the test 4 practice on Newton. You have 3 attempts, but the deadline to take the test 4 practice is tomorrow at midnight. Okay, we'll look at another word problem from this one. An arrow is shot upward at a rate of 220 feet per second. Use the projectile formula h equals negative 16 t to the second plus v sub 0 times t to determine when the height of the arrow will be 400 feet. Round your answer to the nearest tenth. Okay, in this formula, the v sub 0 represents the initial velocity of the arrow, and that is given to be 220 feet per second. Okay, and this formula, h, represents the height of the arrow, t seconds after it's shot upward. So first, we'll replace v sub 0 with 220 because that's the initial velocity. So the height of the arrow, t seconds after being shot upwards, is negative 16 t to the second plus 220 times t. So I'll just make a note of that. This is the height of the arrow. Measured in feet. T seconds after it's fired upwards. Or shot upwards. Okay, they want to know how many seconds it will take until the height of the arrow is 400 feet. Well, in this particular case, there's going to be two solutions because when the arrow is shot upwards, at some point it's going to reach 400 feet on the way up, but then when it comes back down, it's also going to be at that height a second time on the way down. So we're looking for two values for t to solve this. So the way we do it, we replace h with 400 and then proceed to solve the equation for t. Okay, this equation is a quadratic equation in the variable t, and we know how to solve every quadratic equation. So what I'm going to do, I'm going to add 16t to the second to both sides and subtract 220t from both sides, and we'll get the standard equation. 16t to the second minus 220t plus 400 equals 0. You can use the quadratic formula with these numbers, but notice that the numbers 16, negative 220, and 400, they're all divisible by 4. So if we divide every term on both sides of this equation by 4, we'll get rid of some of the excess. And so we'll just have, we're going to divide every term on both sides by 4. So we'll get 4t to the second minus 55t plus 100 equals 0. And the solutions to this equation are the same as the solutions to the equation above it, but using smaller numbers will make the arithmetic simpler. So we'll go ahead and use the quadratic formula with a equals 4, b equals negative 55, and c equals 100. Okay, so the t-values, the negative of negative 55 plus and minus the square root of the number negative 55 squared minus 4 times 100, all divided by 2 times 4. And now we'll do some arithmetic. The negative of negative 55 is 55, plus and minus the square root of some number, all divided by 8. Okay, the number negative 55 squared. Using a calculator, you can find that that's equal to 3,025. And from that, we are subtracting 4 times 100, or 16 times 100, which is 1,600. And then inside the square root, let's write t equals 55 plus and minus the square root of 1,425, all divided by 8. Well, notice that 1,425 has a factor of 25. 25 times 57 equals 1,425. So 25 is a perfect square factor of 1,425. So we'll take that a little further. T equals 55 plus and minus. I'll write it as the square root of 25 times the square root of 57, all over 8. And then t equals 55 plus and minus 5 times the square root of 57, all divided by 8. Okay, the problem says round your answer to the nearest tenth. So there are 2 answers. So one is 55 minus 5 times the square root of 57, all divided by 8. So use a calculator to get this number and round it to 1 decimal place, round it to the nearest tenth. And then the t-value, the height, or the arrow reaches 400 feet on the way back down when t is equal to 55 plus 5 times the square root of 57, all divided by 8. Okay, so roughly, the square root of 57 is a little bit less than 8. So if you just want to get an estimate without using a calculator, 5 times 8 is 40. 50 minus 40 is 15. 15 divided by 8 is a little bit less than 2 seconds. So when you're using a calculator, you can use your estimate to see if your calculator does what you want it to do. And then over here on the way down, so 5 times 8 is 40, 55 plus 40 is 95, and 95 divided by 8 is a little bit less than 12. So okay, we'll move on. In section 9.8, this is the section on solving quadratic inequalities. So this kind of inequality, we want 0 to be on one side, and we want to know the x values that make the left-hand side 0. Those are the endpoints. So to find the endpoints, we want to know what the factors are if we can factor it. And this one factors pretty nicely. So if we solve this equation, x squared minus 10x plus 21 equals 0, we can solve by factoring. One factor is x minus 3, the other one is x minus 7. And so the endpoints of the intervals are x equals 3 and x equals 7. So we go through the process of plotting the numbers on the number line, 3 and 7. Those two numbers divide the number line into 3 separate intervals. And then we pick a test point from each interval. In the interval on the left, we can pick x to be 0. And then in the inequality, replace every x with 0. We get 21 greater than or equal to 0. That's true. So all of the numbers from negative infinity to negative 3 are solutions. In the second interval, from 3 to 7, pick any number you want between 3 and 7. So let's pick 4. So we can use the original inequality, but we can also write the inequality where the trinomial is in factored form instead. So we can write the inequality as x minus 3 times x minus 7 is greater than or equal to 0. And then for numbers, for test points that are not 0, it might be easier to use the factored form in the inequality. So if you replace x with 4, this factor, 4 minus 3, is 1. The other factor, 4 minus 7, is negative 3. And this is a negative number, but a negative number greater than or equal to 0 is false. So that means none of the numbers from 3 to 7 are solutions. And then in the third interval, we can pick any number we want greater than 7, so I'll pick 8. And then I'll use the factored form again. 8 minus 3 is 5. The other factor, 8 minus 7, is 1. 5 times 1 greater than or equal to 0 is true. So all the numbers from 7 to infinity are solutions. We include the endpoints. Oftentimes I don't test the endpoints, but let's just test x equals 3 and x equals 7. Okay, in the factored form, when you test 3 minus 3 is 0. And 3 minus 7 is negative 4, but 0 times negative 4 is 0. So we get the inequality 0 greater than or equal to 0. We get the same inequality when we test 7 because this factor is 7. This factor becomes 0 when x is 7. And 4 times 0 is 0, so 0 greater than or equal to 0. That is true. It's the or equal to 0 that makes it true. So we include both endpoints. Graphically, that means we put a bracket. And then the interval notation is parenthesis negative infinity comma 3 bracket. And then the union symbol, bracket 7 comma infinity. This is the interval notation, and then the algebraic notation, x is less than or equal to 3, or x is greater than or equal to 7. Well, let's do the next two just for practice. So this one, x squared is less than 5x, sorry, let me start over. X squared minus 5x minus 24 is less than or equal to 0. We want one side to be 0. We already have that. And we want to know what the endpoints are. We can factor x squared minus 5x minus 24 easily enough. One factor is x plus 3, and the other factor is x minus 8. So if we just have one side 0 and factor the other side, even though I didn't convert it to an equation, we can still identify the endpoints by the factors. Okay, so the x value that makes x plus 3 0 is negative 3, and the x value that makes x minus 8 0 is x equals 8. So these are the endpoints, negative 3 and positive 8. So I'll just make a note of that. Negative 3 and 8 are the endpoints. Okay, so we'll plot those numbers. Negative 3 and 8, 3 intervals. So in the first interval, we can pick negative 4 as a test point. And I'm going to use the factored form. Negative 4 plus 3 is negative 1. Negative 4 minus 8 is negative 12. And negative 1 times negative 12 is 12. The inequality less than or equal to 0 is false. So none of the numbers from negative infinity to negative 3 are solutions. In the second interval, 0 is in that interval, so I'll pick x to be 0. We can use either inequality, but the original inequality is more convenient when 0 is the test point. Replace every x with 0, we get negative 24 less than or equal to 0. That's true. So all the numbers between negative 3 and 8 are solutions. And then finally, in the third interval, pick a number greater than 8. So we can pick 9. And then if we use the factored form, 9 plus 3 is 12. 9 minus 8 is 1. Positive 12 times positive 1 less than or equal to 0 is false. So none of the numbers from 8 to infinity are solutions. And we include the endpoints because each of the two endpoints gives us 0 less than or equal to 0, which is true. So include the endpoints. Graphically, we put a bracket at negative 3 and at positive 8. And all the numbers from negative 3 to 8 are solutions. The interval notation is bracket negative 3 comma 8 bracket. And then the algebraic notation, negative 3 is less than or equal to x, which is less than or equal to 8. Okay, one more quadratic inequality. Well, we want to find the endpoints, and it's not apparent how to factor this. Every polynomial can be factorable or is factorable, but not every polynomial can be factored with integer coefficients. So we want to find the endpoints by solving the equation x squared plus 4x plus 10 equals 0. So we'll use the quadratic formula. So a is 1, b is 4, c is 10. Okay, so we get x equals -4 plus and minus the square root of 4 to the second minus 4 times 1 times 10, all divided by 2 times 1. So x equals -4 plus and minus, inside the square root, 4 squared is 16. 16 minus 4 times 1 times 10 is 16 minus 40, which is -24. And then divide it all by 2. We don't need to proceed any further because the solutions to that equation are non-real numbers. So that means there aren't any real numbers to divide the real number line into separate intervals. So there's only one interval to test. It's the entire number line. There are no real numbers that divide the number line into separate intervals, so there's only one interval to test. So we can pick as a test point any number that we want between -infinity and +infinity. But we might as well just use the simplest number to use of all, which is 0. In the inequality, replace every x with 0, we're left with 10 greater than 0. And so that's true. So that means all real numbers are solutions. So all real numbers are solutions. The interval notation for all real numbers is parenthesis -infinity, comma, infinity, parenthesis. So this is the interval notation for all real numbers. Okay, let's move on to the chapter 11 material. So the distance formula and equations of circles. Find the distance between the points -4, 9, and 7, 5. Okay, so a little bit of background. In the xy plane, every point corresponds to an ordered pair of points. So the number on the left is the x coordinate, the number on the right is the y coordinate. And we want to find the distance between those 2 points. One way to find the distance is to plot the points in the xy plane, construct a right triangle. The hypotenuse of the right triangle is the line segment that connects the 2 points. And then you can find the the length of the two legs of that right triangle and then use the Pythagorean theorem to find the distance between the 2 points. The length of the hypotenuse is the distance between the 2 points. But we also have a distance formula that is derived by using the Pythagorean theorem. So I'll write down the distance formula here. The distance between x1, y1 and x2, y2 in the xy plane is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Square root of that is the distance. Okay, so we can pick either of the 2 points as x1, y1, and the other one as x2, y2. So we'll start with the x-coordinates of the 2 points. The x-coordinates are -4 and 7. So the distance is the square root of, I can write -4 minus 7 quantity squared, and then plus the difference, the square of the difference in the y-coordinates. The y-coordinates of the 2 points are 9 and 5, so I can write plus the quantity 9 minus 5 squared. Okay, so whatever this number is, the square root of all of that is the distance between the 2 points. But we do want to simplify as much as possible. So in this set of parentheses, -4 minus 7 is -11. So inside the square root, we have the number -11 squared. And then we're adding that to the other number. 9 minus 5 is 4, so it's plus 4 squared. Inside the square root, the number -11 squared is positive 121, and we're adding that to 4 squared, which is plus 16. And then we get the distance is equal to the square root of 137. Okay, the square root of 137 cannot be simplified any further. So this is an exact answer. The positive square root of 137. But on the final exam, which is going to be taken on Newton, it's possible that you'll need to convert this or round it to a decimal number. Write a decimal number rounded to, say, the nearest tenth or the nearest hundredth. And so you can use a calculator for that to round this to a certain number of decimal places. One thing we know is that this number is between 11 and 12. So just making that observation might be worthwhile in the event that when you're converting it to a decimal number, you mistakenly type in a number and get an off answer. Okay, let's find the distance between the next 2 points. So on this one, find the distance between the points 10, -6, and -4, -2. So we have some examples that involve negative numbers so that you can iron out any of the problems you have with arithmetic involving negative numbers. So first we'll focus on the x-coordinates. The x-coordinate of this point is 10. The x-coordinate of the other point is -4. So one option is inside the square root to write in parentheses 10 minus -4 quantity squared. And then plus, now we focus on the y-coordinates. This y-coordinate is -6. This y-coordinate is -2. So we can write in parentheses -6 minus 2, minus, see what I mean? -6 minus -2, quantity squared. All it takes is one little mistake to throw everything off. So now we'll do a little bit more arithmetic. Inside this set of parentheses, 10 minus -4 is the same as 10 plus 4, quantity squared. And then inside this set of parentheses, -6 minus -2 is the same as -6 plus 2, quantity squared. This is more detail than is absolutely necessary, but it might be worthwhile practice. So inside this set of parentheses, 10 plus 4 is 14, so we get 14 squared. And -8 plus 2 is -4, so we get -4 squared. Okay, then 14 squared is 196, and the number -4 squared is 16. And so we get the distance equals the positive square root of 212. This square root can be simplified further. 4 times 53 equals 212. So this can be written as the square root of 4 times the square root of 53. And the square root of 4 is 2. 2 times the square root of 53. If in Newton, say, you were just supposed to give a decimal approximation, then you could just take the square root of 212 and round it to a decimal. Okay, now we'll move on to circles. In this problem, it says write the standard equation of a circle centered at the ordered pair 7, -4 with radius square root of 3. So I'll write down the standard equation. If the center is the ordered pair HK, and if the radius of the circle is R, then the standard equation for that circle is the quantity x minus h squared plus the quantity y minus k squared equals the radius squared. Okay, so h and k just represent real numbers. So h and k can be positive or negative. But this is how you write the standard equation. Okay, so if the x-coordinate of the equations, or of the circle's center is 7, then in the standard equation we write the quantity x minus 7 squared, and then we're going to add that to the next term. The y-coordinate is -4. So in the standard equation for this circle, we write y minus -4 quantity squared. And the radius is the square root of 3. So in the standard equation, we square the radius. Okay, this is a good start, but we want to take it further. The x minus 7 quantity squared is the way that we want it, but y minus -4 quantity squared, we want to write this as y plus 4 quantity squared. And then the square root of 3 times squared is the square root of 3 times the square root of 3, which is the square root of 9, and the square root of 9 is 3. Okay, so that's the standard equation. It might look kind of weird to have a number that's not squared over here, or a perfect square, but it could happen. Okay, one more example similar to that one. Write the standard equation of a circle with center -3, 2 and radius 9. The x-coordinate of the center is -3, so we write the quantity x minus -3 squared, and then plus the y-coordinate of the center is 2, so plus the quantity y minus 2 squared. The radius is 9, so the right-hand side is 9 squared. And we want to simplify a little bit. X minus -3 is equivalent to x plus 3. So we have x plus 3 quantity squared plus y minus 2 quantity squared, and then 9 squared is 81. So this is the standard equation of that circle. Okay, the next thing we'll do is write equations of circles in two standard form when they're not given in standard form. Okay, write the equation of the circle x squared minus 7x plus y squared plus 5y plus 11 equals 0 in standard form. Okay, so it might not look like the equation of a circle, but this is an equation of a circle. It's just not in standard form. Okay, so we can get it into standard form. In this case, we're going to have to complete the square twice. So we'll write x squared minus 7x. We're going to leave some space for the completing the square part before I write plus y squared plus 5y. Leave some space. And we also, in this first step, we want to subtract 11 from both sides. So the right-hand side becomes -11. Okay, in the next step, we're going to add two numbers to both sides of the equation. And the numbers that we add are the numbers that we need to create two perfect square trinomials. So we'll first add a number to both sides so that when we add that number to x squared minus 7x, we'll get a perfect square trinomial. And then we'll add another number to both sides. When we add that number to y squared plus 5y, we'll get another perfect square trinomial. Okay, so we'll start with the x terms. Since the coefficient of x squared is 1, how do we find the number to add to x squared minus 7x so that we get a perfect square trinomial? Well, what we do is we take 1/2 of -7. So up here at the top, I'll write what we're going to do. We're going to take 1/2 of -7, which is -7/2. And then we're going to square that number, square the number -7/2. And the number negative 7 halves squared is positive 49/4. So that's the number that we're going to add to both sides of the equation, 49/4. And now we have a perfect square trinomial. Okay, we'll do the same, go through the same process to create a perfect square trinomial out of this, y squared plus 5y. Well, the coefficient of y squared is already 1. That's what we need. And then we take 1/2 of the coefficient of y. So this time we take 1/2 of 5, which is 5 halves. And then we square 5 halves. So 5 halves times 5 halves is 25/4. So we're going to add 25/4 to both sides. And now we have another perfect square trinomial. Okay, so in the next step, we're going to replace this perfect square trinomial with a binomial squared. So some binomial squared is equal to the trinomial x squared minus 7x plus 49/4. Well, we know that the binomial squared has to have an x in it. And what follows x? It's the same number we got when we took 1/2 of negative 7. 1/2 of negative 7 is negative 7 halves. So we write minus x minus 7 halves. Okay, then in the next perfect square trinomial, same kind of thing. So what binomial do we square to get the perfect square trinomial, y squared plus 5y plus 25/4? The binomial has to have y in it, and then what follows y? What follows y is the same number that we got when we took 1/2 of 5. When we took 1/2 of 5, we got 5 halves. So we're going to add 5 halves. Okay, then on the right-hand side, we have to add these numbers. We need a common denominator. Negative 11 is equivalent to negative 44/4. And we're adding that to 49/4 plus 25/4. We can do that. Since the denominators are the same, negative 44 plus 49 is positive 5, so 5/4. And then 5/4 plus 25/4 is 30/4. And we can write that fraction in lower terms, so we'll do that. So the standard equation is x minus 7 halves squared plus y plus 5 halves squared equals 15/2. Okay, there's a little over 5 minutes left. I mentioned before in an email and somewhere else that on test 4 there will be some review problems from before test 4 material. So one type of problem are solving rational inequalities. So let's go through this one. Solve this inequality. 3x minus 2 over x minus 4 is greater than or equal to 2. We want one side to be 0, just like we do with quadratic inequalities. So we're going to subtract 2 from both sides so that the right-hand side is 0. And then we want to write the left-hand side as a single rational expression with a common denominator. So the least common denominator is x minus 4. So we can write this as 3x minus 2 over x minus 4 minus 2 times x minus 4 divided by x minus 4. And then in the next step, we can follow the arithmetic. So let's look at the x coordinates in the numerators. We have 3x, and we're going to subtract 2 times x. So 3x minus 2x is just 1x. And now we'll follow the constants. So this is negative 2 minus 2 times negative 4. Okay, so maybe on this one I'll write it out in a little more detail. Negative 2, and we're subtracting 2 times negative 4. This is greater than or equal to 0. So we have x minus 2, and we're subtracting 2 times negative 4. So we're subtracting negative 8, which is equivalent to adding 8. And then one more step in the numerator, x minus 2 plus 8 is x plus 6 over x minus 4 is greater than or equal to 0. And now we can identify the endpoints. The endpoints are the x values that make the numerator 0 combined with the x values that make the denominator 0. So the endpoints are x equals negative 6 and x equals positive 4. So we plot those numbers on the number line, negative 6 and 4. So in the interval on the left, we can pick x to be, say, negative 7. And then in this inequality, in the numerator, negative 7 plus 6 is negative 1. In the denominator, negative 7 minus 4 is negative 11, or positive 1 over 11. And 1/11 greater than or equal to 0 is true. So all the numbers from negative infinity to negative 6 are solutions. And in the second interval, we can pick x to be 0. And when x is 0, we get 6 divided by negative 4 greater than or equal to 0. That's false. So none of the numbers between negative 6 and 4 are solutions. And in the third interval, we can pick x to be 5. So this time, replace x with 5. 5 plus 6 is 11. In the denominator, 5 minus 4 is 1. And the inequality greater than or equal to 0 is true. So yes, the numbers from 4 to infinity are solutions. Endpoints that come from denominators are never included. So we put a parenthesis at 4. But this endpoint from the numerator is included because that's what makes the left-hand side 0, and the or equal to 0 makes it true. So we include negative 6. So I'll just write down the interval notation for the solution. It's negative infinity, comma, negative 6, bracket, and then union, parenthesis, 4, comma, infinity. Okay, we still have tomorrow to review for the test 4. So tomorrow, I'll look at these other review problems that will be on test 4 involving simplifying radicals. And I'll have a bunch of other stuff to review also. Okay, that's all for today, I guess. We'll start in about a minute. We'll continue the test 4 review, and test 4 is on Friday. You should take advantage of the test 4 practice on Newton. It's going to shut down tomorrow night at midnight, so you won't be able to use the test 4 practice if you wait too long. And tomorrow we don't meet, so this is the last chance to review. Okay, we have another word problem to look at. This one says an arrow is shot upward at a rate of 220 feet per second. Use the projectile formula h equals negative 16 t to the second plus v sub 0 times t to determine when the height of the arrow will be 400 feet. Round your answer to the nearest tenth. Okay, a couple of things about this projectile formula. T is measured in seconds. V sub 0 is the initial velocity of the arrow, and that is given to be 220 feet per second. H represents the height of the arrow t seconds after it is shot upward. And you'll note that when t equals 0, the height of the arrow above the ground is 0 feet. So it's, in other words, it's at ground level at the instant that it's shot upward. So if we want to determine how many seconds it takes until the arrow is at a height of 400 feet above the ground. So if you think about it, that's going to happen twice. If the arrow goes high enough, then the arrow will reach 400 feet on the way up, and then it will also be at 400 feet on the way down. Okay, so first let's write the projectile formula with the given initial velocity of 220 feet per second. So the height of the arrow t seconds after being shot upwards is negative 16 times t to the second plus 220 t. So we want to find the values of t when h is 400. So it helps to understand what a formula means. It helps to be able to answer the question. So we're going to replace h with 400 and then solve the resulting equation for t. So replace h with 400, so we get 400 equals negative 16 t to the second plus 220 t. This is a quadratic equation in the variable t, and we know how to solve any quadratic equation whatsoever. So what I'm going to do, I'm going to add 16t to the second to both sides, and I will also subtract 220t, and the equation in standard form will look like 16t to the second minus 220t plus 400 equals 0. We can proceed to use the quadratic formula with values a equals 16, b equals negative 220, and c equals 400. But I want to pare it down a little bit because I note that 16, negative 220, and 400 have a greatest common factor of 4. So I can get rid of some of the clutter that's in the way if I divide every term on both sides by 4. So I'm going to do that. Divide every term on both sides by 4. We'll get 4t to the second minus 55t plus 100, and 0 divided by 4 is 0. The solutions to this second equation are exactly the same as the solutions to the equation above it, but with smaller coefficients and constants, the arithmetic will be a little bit easier. Okay, so for this equation, we could use a equals 4, b equals negative 55, and c equals 100. So t is equal to the negative of negative 55 plus and minus the square root of the number negative 55 squared minus 4 times 100, all divided by 2 times 4. Okay, now the arithmetic. So the arithmetic is sort of important if we want to get the right answers. So the negative of negative 55 is positive 55 plus and minus the square root of some number, all divided by 8. Okay, the number negative 55 squared, that's just 3025. And we're subtracting 4 times 100, or you can think of it as subtracting 16 times 100. 16 times 100 is 1600. So we're subtracting 1600 from 3025 inside the square root. Okay, so inside the square root, 3025 minus 1600 is 1425. Note that 25 is a factor of 1425. 25 will go into 1425 57 times. So let's write this as t equals 55 plus and minus the square root of 25 times the square root of 57, all divided by 8. And then in the next step, we'll simplify the square root of 25. So we get t equals 55 plus and minus 5 times the square root of 57, all divided by 8. Okay, there are 2 answers that make sense, as discussed earlier. So on the way up, or just shortly after being fired, the arrow will reach 400 feet when t equals 55 minus 5 times the square root of 57 divided by 8. And then a little bit later, on the way down, the arrow is at 400 feet again when time is equal to 55 plus 5 times the square root of 57, all divided by 8. So these are measured in seconds. Okay, so I'll leave the rest of this for you to do, I'll just make a couple of comments. Make sure that you know how to get your calculator to tell you what you want it to tell you. So we can observe an approximate answer. The square root of 57 is between 7 and 8. So if you just round it up to 8, 5 times 8 is 40. 55 minus 40 is 15, and 15 divided by 8 is a number a little bit smaller than 2. So when you key this into your calculator, you're looking for a number that's around 2 seconds. Not exactly 2 seconds, but close to 2 seconds. And then similarly, over here, the square root of 57 is between 7 and 8. If you just round it up to 8, 5 times 8 is 40. 55 plus 40 is 95. And 95 divided by 8 is a little bit smaller than 12. So this answer should be close to 12 seconds. Okay, moving on, we'll look at the next section. Solving quadratic inequalities. When solving quadratic inequalities, we want one side to be 0. We already have one side equal to 0. And we want to find the endpoints. The endpoints are the x values that make x squared minus 10x plus 21 equal to 0. So we can solve the quadratic equation, x squared minus 10x plus 21 equals 0. The solutions are the endpoints, if the solutions are real numbers. And we can solve this equation easily enough by factoring. One factor is x minus 3, and the other one is x minus 7. So the endpoints, the numbers that divide the number line into separate intervals are x equals 3 and x equals 7. Another thing that I've done before, rewrite the inequality with the left-hand side in factored form. So you can use the inequality x minus 3 times x minus 7 is greater than or equal to 0 if you want to use this when testing points. Okay, but we might as well stop stalling and get to testing. So plot the points 3 and 7. Those numbers divide the number line into 3 separate intervals. In the interval on the left, we can pick any number less than 3. So let's pick 0. When x is 0, in the original inequality, replace every x with 0, we get 21 greater than or equal to 0, and that's true. So yes, all of the numbers from negative infinity to 3 are solutions. In the second interval, pick any number you want between 3 and 7, so I'll pick 4. So we can use the original inequality, that's not too hard, but with non-zero numbers for test points, using the factored inequality might be easier. So replace every x with 4. 4 minus 3 is 1. 4 minus 7 is negative 3. And this is a negative number. A negative number greater than or equal to 0 is false. So none of the numbers between 3 and 7 are solutions. And then in the third interval, we can pick x to be any number greater than 7. So I'll pick x to be 8. And then I'll use the factored form again. Replace x with 8. 8 minus 3 is 5. 8 minus 7 is 1. 5 times 1 greater than or equal to 0 is true. So yes, all of the numbers from 7 to infinity are solutions. Now, oftentimes I just explain why or why not the endpoints are included. But let's test the endpoints. Test x equals 3 and x equals 7. So using the factored form might be easier. If you test x equals 3, then this factor, 3 minus 3 is 0. The other factor is negative 7, but 0 times negative 7 is 0. And the inequality 0 greater than or equal to 0 is true. It's the or equal to 0 that makes it true. And the same thing happens when you test 7. So 7 minus 3 is 4, but 7 minus 7 is 0. 0 times 4 is still 0, so the same thing applies here. 0 greater than or equal to 0 is true. So we include both endpoints. Graphically, that means we put a bracket at the endpoints, a bracket at 3 and shade to the left, a bracket at 7 and shade to the right. And then write the interval notation and the algebraic notation. The interval notation for this part of the number line is parenthesis negative infinity, comma 3 bracket. And then we put the union symbol. The other part of the solution is bracket 7 comma infinity. The algebraic notation. So the x values that are in this interval on the left, that means x is less than or equal to 3. But solutions that are not in the interval on the left have to be in the interval on the right, and those are x greater than or equal to 7. Okay, a couple of more quadratic inequalities. X squared minus 5x minus 24 is less than or equal to 0. So let's just write down the inequality with the left-hand side in factored form, since we can easily factor x squared minus 5x minus 24. One factor is x plus 3. The other factor is x minus 8. So x plus 3 times x minus 8 is less than or equal to 0. And we can use the factors to find the endpoints. So I'll just be a little bit more explicit. The endpoints are x equals negative 3 and x equals 8. So we'll get started. Plot the numbers negative 3 and 8. Those two numbers divide the number line into 3 separate intervals. So in the interval on the left, I'll pick x to be negative 4. And I'm going to use the factored form of the inequality. Replace x with negative 4. Negative 4 plus 3 is negative 1. Negative 4 minus 8 is negative 12. But this is a positive number. Negative 1 times negative 12 is 12. 12 less than or equal to 0 is false. And then in the second interval, pick any number you want between negative 3 and 8. We can pick 0. And using the original inequality is usually the easier choice when 0 is the test point. Replace every x with 0. We're left with negative 24 less than or equal to 0. And that's true. So yes, the numbers between negative 3 and 8 are solutions. And then in the third interval, pick any number you want greater than 8. So we can pick x to be 9. And then I'll use the factored form. 9 plus 3 is 12. 9 minus 8 is 1. 12 times 1 less than or equal to 0 is false. So none of the numbers from 8 to infinity are solutions. Because of the or equal to 0 part, both endpoints are included. So we put a bracket at the endpoint -3, put a bracket at the endpoint 8, and graphically we shade in the numbers between -3 and 8. The interval notation for this solution is bracket -3 comma 8 bracket. And the algebraic notation, if x is a number in this interval, then -3 is less than or equal to x, and at the same time, x is less than or equal to 8. Okay, one more quadratic inequality. X squared plus 4x plus 10 is greater than 0. Well, even though every polynomial is factorable, not all polynomials are factorable with integer coefficients. So we cannot factor x squared plus 4x plus 10 with integer coefficients. So we have to find the endpoints by solving the equation x squared plus 4x plus 10 equals 0. So we can use the quadratic formula with a equals 1, b equals 4, and c equals 10. So I'll make a note of that. A equals 1, b is 4, c is 10. So the solutions, x equals -4 plus and minus the square root of 4 squared minus 4 times 1 times 10, all divided by 2 times 1. And then in the numerator, -4 plus and minus the square root of some number, all divided by 2. Okay, so inside the square root, 4 squared is 16, and we're subtracting 4 times 1 times 10. 16 minus 40 is -24. Okay, for what we're doing, we don't need to simplify further because we know that the two solutions are non-real numbers. So that means there are no endpoints to divide the entire number line into separate intervals. But there is one interval, and that's the entire number line. So we still have to test this one interval. And so we can pick any number we want as a test point between -infinity and +infinity. So we might as well just pick x to be 0, since that's a number on the number line. And then when you replace every x with 0, you get 10 greater than 0, and that's true. So this tells us that every real number between -infinity and +infinity is a solution to that inequality. So in words, you could say all real numbers are solutions. All real numbers are solutions. The interval notation for all real numbers is parenthesis -infinity, comma, infinity, parenthesis. That's the interval notation for the set of all real numbers. Okay, now we'll move on to the chapter 11 material on the distance formula and circles. Okay, find the distance between the points -4, 9, and 7, 5. Okay, so a little background. In the xy plane, every point can be represented by an ordered pair of points. The number on the left is called the x-coordinate. The number on the right is called the y-coordinate. So you can use the distance formula to find the distance between any 2 points in the xy plane. So I'll write down the distance formula. The distance formula is derived by using the Pythagorean theorem. So the distance between the points x1, y1 and x2, y2, or the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared, square root of that. We can identify one of the ordered pairs as x1, y1 and the other one as x2, y2, but it doesn't matter which is which. The formula works regardless. Okay, so we'll apply the distance formula to this particular case. So first, let's focus on the x-coordinates. One x-coordinate is -4. The other x-coordinate is 7. So inside the square root, we can write the quantity -4 minus 7 squared, -4 minus 7 quantity squared, and then plus, now we focus on the y-coordinates. One y-coordinate is +9 and the other one is +5. So inside the square root, we have plus the quantity 9 minus 5 squared. And then we do the arithmetic. So -4 minus 7 inside this set of parentheses is -11, and we have to square -11. And then we're adding that to this number. 9 minus 5 inside the parentheses is 4, so it's +4 to the second. When we square the number -11, we get positive 121, and then when we square 4, we get 16. And then we get the distance is the square root of 137. The square root of 137 cannot be simplified further than that. But eventually on the final exam, you might have to round this to the nearest tenth. So make sure that you know how to use a calculator. I'm sure that you already know how to do that, but just take the square root of 137, and if you round it to the nearest tenth, that means round it to 1 decimal place. If it says round to the nearest hundredth, then round it to 2 decimal places. Okay, we'll do another example. So make sure that you have all of the issues regarding adding and subtracting positive and negative numbers. Make sure that you have all of those worked out. All it takes is one mistake to throw everything off. Okay, so we'll use the distance formula to find the distance between the point 10, -6, and the point -4, -2. Okay, so the distance is the square root of some stuff. So let's focus on the x-coordinates. This x-coordinate is 10, the other one is -4. So inside the square root, we have 10 minus the number -4 squared, quantity squared, and then plus something else. Now we focus on the y-coordinates. This y-coordinate is -6. The other y-coordinate is -2. So inside the square root, we have plus the quantity -6 minus -2 quantity squared. Okay, in this set of parentheses, 10 minus negative 4, that's equivalent to 10 plus 4, quantity squared. And then in the other set of parentheses, negative 6 minus negative 2, that's equivalent to negative 6 plus 2, quantity squared. So we're getting there. 10 plus 4 is 14, so we have 14 squared. And negative 6 plus 2 is negative 4, so we have plus negative 4 squared. Uh, 14 squared is 196. The number negative 4 squared is positive 16. And so the distance is the square root of 212. If in the end you're supposed to round it to a decimal, then you could just use your calculator to compute the square root of 212 and round it. On the other hand, if you're going to give an exact answer in terms of the square root, this square root can be simplified. 4 is a factor of 212. 4 times 53 is 212, so this can be written as the distance equals the square root of 4 times the square root of 53. And then the square root of 4 is 2, so 2 times the square root of 53. Okay, now we'll start talking about circles. This one says, write the standard equation of a circle centered at the ordered pair 7, negative 4, and with radius the square root of 3. So I'll write down in general, if the center of a circle in the xy plane is the point HK, that means the x coordinate of the center is H and the y coordinate of the center is K. And if the radius of the circle is R, then the standard equation for that circle is the binomial x minus h squared plus the binomial y minus k squared equals the radius squared. So if you remember, this standard equation of a circle is just the Pythagorean theorem applied to a right triangle. Okay, so for this circle, if the center is the ordered pair 7, negative 4, and the radius is the square root of 3, then we can write down the standard equation for that circle. The x coordinate is 7, so x minus 7 squared, square the binomial x minus 7, and then we add that to the binomial y minus negative 4 squared. And then the right-hand side, the square root of 3 squared, the radius squared. Okay, this is a good start, but we want to simplify further. X minus 7 quantity squared is already as simplified as we want it to be. And then plus, instead of y minus negative 4, we write that as y plus 4 quantity squared. And then when we square the square root of 3, that's just equal to 3. So this is the standard equation for that circle that we want to write. Okay, the next one is the same kind of exercise. This time the center is the ordered pair negative 3, 2, and the radius is 9. So we can start by writing x minus the x coordinate negative 3 quantity squared plus the quantity y minus 2 squared equals 9 squared, the radius squared. This is not as simplified as we want it to be. Instead of x minus negative 3, we write x plus 3 quantity squared. The next term is already complete, y minus 2 quantity squared. And then 9 squared we write as 81. So this is the standard equation that we want to write in this case. Okay, the next example is an equation of a circle that's not in standard form, and then we have to write it in standard form. Hey, write the equation of a circle. I guess it should be of the circle, x squared minus 7x plus y squared plus 5y plus 11 equals 0 in standard form. Okay, so we'll write out x squared minus 7x. We'll leave some space before we put the plus y squared because we're going to, the implication is we're going to create a perfect square trinomial by adding the appropriate number. And then we have plus y squared plus 5y. Leave some space again because we're going to create a second perfect square trinomial. And we want the constant moved to the opposite side. So we have to subtract 11 from both sides. And then in the next step, we're going to add two numbers to both sides of the equation. And the two numbers that we add are going to create, in the process, it will create two perfect square trinomials. Okay, so first focus on x squared minus 7x. It's important to note that the coefficient of x squared is 1. So when the coefficient of x squared is 1, we can apply a process to help us complete the square or to create a perfect square trinomial. Okay, so what we do is we take 1/2 of the coefficient of x and square it. So up here at the top, I'm going to write what the process is. 1/2 of -7 is -7/2. And then we square that number. The number -7/2 squared is positive 49/4. So that is the number that we're going to add to both sides. It's the number that completes the square on x squared minus 7x. So x squared minus 7x plus 49/4 is now a perfect square trinomial. Okay, we're also going to create a perfect square trinomial out of the y squared plus 5y. Note the coefficient of y squared is 1, so that means we can take 1/2 of the coefficient of y, so 1/2 times 5 is 5/2. Then we're going to square that number, 5/2. 5/2 squared is 25/4. So we're going to add 25/4 to both sides of the equation. So now y squared plus 5y plus 25/4 is a perfect square trinomial. Okay, so in the next step, we can write down what binomial we have to square to get this perfect square trinomial. We're going to add that to another binomial squared that's equal to this trinomial. And on the right-hand side, we have to add three numbers. We have to have a common denominator. So we'll do part of that work up here. The least common denominator is 4, so replace -11 over 1 with -44 over 4, and we're adding that to 49/4, which we're adding to 25/4. Okay, we might as well do that. Complete the right-hand side. -44/4 plus 49/4 is 5/4. And then 5/4 plus 25/4 is 30/4. This can be written in lower terms. Okay, but how do we know what binomial to square to get x squared minus 7x plus 49/4? We know the binomial has to have an x in it because x times x is x squared. The number that follows x is the same number we got when we took 1/2 of -7. So 1/2 of -7 is -7/2. So that means we write minus x minus 7/2 quantity squared. And then the same sort of thing here. The binomial has to have y in it because y squared is y squared. And then how do I know what follows? Well, what follows is the same number I got when I took 1/2 of +5, which is +5/2. So that means we add 5/2. Okay, the right-hand side can be written in lower terms. So this is 15/2. So let's identify the center and the radius. The x-coordinate of the center is +7/2. The y-coordinate of the center is -5/2. And the radius is the square root of this number. The square root of 15/2 is the radius. This probably should be simplified a little bit. So it's the square root of 15 over the square root of 2. Then multiply by, to rationalize the denominator, multiply by 1 in the form of the square root of 2 over the square root of 2. So we get the square root of 30 over 2. This is the radius in simplified form. Okay. So graph the circle, x plus 4 squared plus y plus 3 squared equals 4. Well, it's easy to make a mistake if you're not careful. The center is -4 for x and -3 for y. And since the right-hand side of this equation in standard form is the radius squared, the radius is the square root of 4, which is 2. So if you're sort of not paying attention, you could easily mistake the radius. Anyway, plot the point -4, -3. And then the radius is 2, so we can find 2 points on the vertical line that's through the center, 2 points on the horizontal line, and then attempt to draw a circle through those points. Okay, so I'll just label some of the points on the x-axis and on the y-axis. So roughly that's the graph. Okay, there's a little bit more than 6 minutes. You can go through the same process that we did in the previous example up there. Complete the square twice to get the standard equation. This one will be easier than the one that we just did a couple of minutes ago because this one won't involve any fractions. But since this is the last day that we can review for test 4, test 4 will have some review problems on it from prior to test 4. One is a rational inequality. So let's practice this one. When solving rational inequalities, we want one side to be 0. So we have some preliminary work on this one. We have to subtract 2 from both sides. And then we want to write the left-hand side as a single rational expression with a common denominator. So the least common denominator is x minus 4. So if I write x minus 4 over x minus 4, then we have a common denominator, and then we have to make sure we do the arithmetic carefully. So I'll rewrite this as 3x minus 2 over x minus 4, and then minus, in the numerator, multiply 2 times the binomial x minus 4, so we get 2x minus 8 over x minus 4, greater than or equal to 0. And then make sure you're careful with the arithmetic when we write it as a single rational expression with a common denominator x minus 4. We have to subtract every term in that numerator. So we have to subtract 2x, but we also have to subtract negative 8, which is equivalent to adding 8. So this might be a trouble spot if you're not careful. Okay, then we can write the rational expression in completely simplified form. 3x minus 2x is x, and minus 2 plus 8 is plus 6. Okay, now we have the rational inequality the way that we want it. And the endpoints are the x values that make the numerator 0 combined with the x values that make the denominator 0. So the endpoints are negative 6, that comes from the numerator, and x equals positive 4, that comes from the denominator. So like all inequalities, we plot the endpoints on the number line. Those 2 endpoints divide the number line into 3 separate intervals. And then we pick test points from the intervals. In the first interval on the left, pick any number less than negative 6. I'll pick negative 7. And then in the inequality, replace every x with negative 7. In the numerator, negative 7 plus 6 is negative 1. In the denominator, negative 7 minus 4 is negative 11. Negative 1 divided by negative 11 is positive 1 over 11, and the inequality greater than or equal to 0, that's true. So that means all of the numbers from negative infinity to negative 6 are solutions. In the second interval, 0 is in that interval, so I'll pick 0 as the test point. And then in the inequality, replace every x with 0. We get 6 divided by negative 4. That's clearly negative. A negative number greater than or equal to 0 is false. So none of the numbers between negative 6 and 4 are solutions. And then in the third interval on the right, I'll pick x to be 5. And in the inequality, in the numerator, 5 plus 6 is 11. In the denominator, 5 minus 4 is 1. That's clearly positive. A positive number greater than or equal to 0 is true. So all of the numbers from 4 to infinity are solutions. Remember that endpoints that come from denominators are never included. So 4 is excluded from the solution set. Negative 6 is the endpoint that comes from the numerator. And that will be included because when the numerator is 0, 0 greater than or equal to 0 is true. So graphically, we put a bracket at negative 6, but we put a parenthesis at 4. And then the interval notation, for this part, it's parenthesis negative infinity, comma, negative 6 bracket, and then union, parenthesis 4, comma, infinity. Okay, we're about out of time. Just be prepared for simplifying radicals. We don't have time to do these examples right now, but you can review material that we have covered on radicals. Those come from sections 8.1 and 8.2 and 8.3. And if you review those, then that will help. But that's about all we have time for today. So there won't be a YouTube live meeting on Friday because we'll be having the test. Okay, that's all for today.